action.
What did I call it the other
Okay.
Salsa here. Okay.
Without looking at your note packet, can anybody define measurement in their own words?
No.
Hold on.
One, okay, 2 markers equals a credit. I remember that.
Yep.
Measurement is recording something with using a standard unit.
Comparing an unknown to a standard unit or a standard measurement device. Yep, I would say you were pretty spot on there. What?
You get 1 minute.
That's what you were going to say? All right, well, very good, Tanner. Next time have the courage to speak up. All right.
Thanks.
Okay? The act of comparing an unknown quantity to a standard unit. Guys, I want to make it very clear that standard units are man-made. AKA the Kramer. The what?
Using the day of
Yes.
Measurement of time.
Well, all things are created by God, but we assign things to it. You know, like
Like the tree was made out of God that made his desk. God made
Or
the
did
tree.
God,
The tree was made of
God
The tree
created
was made
day,
of God.
so
Isn't that in
God is, yeah, that's it.
God did create
It
day.
is, it does say in the Bible that it was evening and morning hours.
And that was the day.
And there were no people when
Yeah.
he said that.
So,
And there was nothing, so there was light.
sure, but then God's the standard, but there's still a standard, right? You're just saying it's not man-made.
God created light,
Okay,
there's something,
fine.
but.
I can deal with that. Fine. The God spoke a day and a night, and it was a certain time period, but we still had to say that a day is this long, like this much time. We had to assign a time unit to that day. You know, it wasn't just, you know, we had to assign a calendar year to what God created. So yeah. Okay. So the point I'm trying to get here is that okay, most standards are chosen and given by a man or a woman, I guess. Okay. For example, you have heard me talk about the Kramer. It's just I said I can use this to measure length. Okay, the foot. Someone said a foot was yay long. Okay, before they actually made it a more standardized, it was literally your foot. Would you see the problem with that? Yeah, I mean, so anything you could talk about has some sort of standard that we compare it to, and it helps us to be able to compare across boards, across seas, across you know, different people groups. Okay, now unfortunately, sometimes people in America use a different unit than people in Europe.
and everywhere else.
Yeah, and sometimes America thinks they're way better than everybody else and then uses still the really crappy units. Okay, and we're going to talk about that. Anyway. So a dimension is anything in our universe that is measurable. Length is a measurable aspect of our universe. Mass, time, volume, temperature. There's lots of different dimensions. Color. Oh well, can you measure color? You could measure how, yeah, you could measure how, you know, you could measure various levels of color. Unit, this is very important. Units are very, very important in this class. We're going to start in this chapter where we'll start doing some of the unit conversions, and you guys may remember some of them. We're doing that this chapter, but we'll do multiple ones. Like we didn't do multiple ones in physical science. We'll do multiple, more than one step. Did I do that wrong? You're looking at it funny, Rachel. Okay, so I'm just using that to convert a milligram to a gram. Okay, and we're actually going to, at some point, convert a milligram to a kilogram. We'll make it a second step.
Can we relearn what's bigger and smaller?
How much is a gram? Depends on how much.
Kilo is 9.
I will give you the Greek prefixes, not the Greek prefixes,
Yeah.
but they're not Greek, are they?
Yeah.
They're the metric prefixes, they're not Greek prefixes, that's what they are. Greek prefixes are like,
Yeah, you're right.
what you use for naming, like mono, di, tri, tetra, penta. That didn't sound
Depends on
right.
what you.
Okay? Now, why are units important? Because they work very much like you would do numbers in math. If I want to get rid of a number 2 on one side of an equation, how could I get rid of it? I guess it depends on where the 2 is, right? Like if it's an addition subtraction type problem, you would either do the opposite and eliminate it. Okay, if it's a multiplication division, then that's going to be something different. But you can do the same thing for units. If I want to get rid of milligrams, I can cancel it out by dividing by it. If I want to get rid of grams, I can cancel it out by dividing by it. So essentially what I'm doing, and I'm getting ahead of myself, is we're taking 2 equivalent conversions and allowing to go from 2 different units. And we'll go over this when we get to it. I'm just kind of showing you. Alright? Everything needs a unit, because if you tell me that you say this measurement was 10, if you just say this measurement was 10, what's the problem with that, brother?
There, you don't know how much of 10
Okay? 10 donkeys, 10 milliliters. Okay, that's a big deal. And so you're going to see, I think coming up here, is you're going to see the typical metric system, I believe. Oh, instrument. Is that all units? That is. Okay, so instruments is some device that will help you measure. But what's really useful about an instrument then? They really enhance what?
Accuracy.
They enhance our human senses. Okay? So you're saying you can only see so far? You say you can only smell so much? Okay? I realize this is boring stuff. I don't even want to. I hate teaching this. Yeah, well, I can tell. Brevin's almost fallen asleep. This stuff, I hate teaching this stuff. It's no fun.
And rush through it so I can finish my English. I was due this morning. And I'm lucky that I don't have a secret.
Yeah, she said.
Yeah, she was looking pretty good.
Oh yeah. He right down me.
Let's go through this quickly then. I'm not gonna elaborate on this. I don't think it's super crazy.
Thank you.
It's useful. Measurement, act of comparing something to something you know as a standard. Okay? Dimension are the things you measure. The properties of the universe that you measure. Unit is what you add on to your measurement so that I know what you're talking about. It tells you what the standard you compared it with was. Instrument is simply a device that enhances our senses because we are very limited in our abilities, and so we use instruments to help us. There we go. Done with that. Metric system. Oops. Okay, metric system, the only reason why I'm putting this up here is because scientists realize that we need to have one uniform system that we use throughout the whole country so that when I say 20 degrees Fahrenheit and somebody in Europe sees 20 degrees and thinks it's in Celsius and they do their experiment and it blows up, that would be bad. 20 degrees Celsius is a lot warmer than 20 degrees Fahrenheit. That could cause some problems. So they essentially came up with the scientific units. The SI units. And it usually is just the metric system. The reason why I use the metric system is why? Why is that? What's the
multiples of 10?
Yeah, ease of use. Multiples of 10. Okay? They chose the metric system because it's easiest, but they also said we need to have a standard that everyone uses so that we don't cause problems with, well, we don't kill people, essentially. Boom, boom, yeah. Okay? Here are just some dimensions, the typical unit you'll see, the symbols, not overly crazy. That's probably about all I need to say about that. Yeah? You might be asked, what are 2 or 3 dimensions on your test? That's possible. Could you give me a dimension if I asked you to give me 2 or 3 dimensions? you now.
Last time.
Now that it's up there. Okay, we're gonna spend later on this year dealing with this dimension a lot.
Is it really that hard just to put the E at the end for the symbol?
For mole.
Yeah.
Really that hard just to put the E?
Yeah. I don't know, they can't just do little m because that's a different unit.
Meter.
They can't do ml, let's go later.
Why not MO?
That sounds funny. I don't know. I think that's it. Is that it? Oh, there's one. Oh, drive units. Ooh, I remember this?
No.
Oh, yeah.
1 Newton is a derived unit. What is it derived from?
Kilogram times a joule per second or something like that.
Kilogram times a meter per second squared.
Yeah.
That's a derived unit.
The joule is like a Newton.
A joule, no, a joule is a Newton times a
Kilogram.
meter. Yep.
Yes.
Newton times a meter. What else would be a derived unit?
Pascal.
Velocity.
Ask something,
Yeah, I mean, velocity is a meter per second. But that's just a unit. I don't know if that's not derived from something else. We don't give that. A watt, if you take physics, is a derived unit. What else? Tanner laying his head on the chair is a derived unit.
No, it just looks deprived.
Derived sleep.
Five
Okay.
times 65.
We'll deal with this more later. So, power good for today. What do we want to review?
Let's review nouns.
What should we review?
Nouns?
Nouns.
Three names of person, place, thing, or idea. That's
What?
what it is.